Welcome back to our YouTube channel. Today we'll be moving on to the third topic in chemistry, which is separation techniques. So we've talked about mixtures in our last class, and we've been able to establish the fact that mixtures are two or more things, maybe homogeneous or heterogeneous. Homogeneous means that they are all in the same phase. Heterogeneous meaning that they are in different phases, liquid, gases, or solids. So two or more things are mixed with themselves according to the name mixtures. So they are mixed together, you understand? So how do we separate these mixtures? So that is what will bring us to separation techniques. So we know that there are different kind of mixtures. So different kind of mixtures will attract different kind of separation techniques. You understand? So now the first thing on the list is sieving. Sieving is one, if they are all in the same phase, and two, if the phase is solid. So if we have solid particles that are mixed together and they have different shapes, or they have different shapes. You can use shapes, or they are bigger or size bigger than one another, you understand? Then you can use sieve. So the sieve is just like a cloth. Most of the time you use a cloth or an iron that has holes of different sizes. So these sizes will determine the thing that will pass through and the thing that will stay behind. So for example, if you have a sieve of maybe the whole of maybe 1 millimeters, for an example, anything below 1 millimeter will pass through the sieve. Anything above 1 millimeter will stay on top of the sieve. So that will be able to separate these two things from one another. You understand? That is sieving for you. The next one is magnetic separation. If you have some things that can be attracted by the magnet, and we have some things that cannot be attracted by the magnet. For an example, maybe you have a mixture of maybe iron filings, you understand, and then maybe some chalk, dust, and every other thing mixed together. So to separate them, just put a magnet very close to that mixture. So the things that can be attracted by the magnet will be attracted, such as the iron filings. So other things that cannot be attracted by the magnet will stay behind. So you've been able to separate that thing. So that is what separation techniques is all about. So the third one is sublimation. So there are some chemicals, or there are some compounds. Example of ammonium chloride, e.g. ammonium chloride, or iodine, or iodine, as the case might be. So they sublime. I told you what sublimation is in the earlier class. Sublimation is when a compound or an element can go from the solid state directly to the gas state without passing through the liquid stage. You understand? So this ammonium chloride or iodine, they can go from the solid state directly to the liquid state without having to pass to the gas state, without having to pass through the liquid state. So when you heat them, maybe you have a solution or a mixture of that contains ammonium chloride and some other things, so you can just heat it. So when you heat it, ammonium chloride is going to leave the mixture, so you can collect it by using all these condensing things, you understand? So you can use it to collect it, and you're going to get your ammonium chloride in a second place, and your mixture will remain, excluding ammonium chloride. So the next thing now is decantation. So decantation can be used to separate an heterogeneous mixture between solid and liquid. You have a solid and a liquid mixed together. How do you separate them? From what you've been learning, you can know that the solid is going to be under and the liquid is going to be on top. So to decant, you just take a glass rod or a metal rod, put it on top of another container, and you start pouring the liquid inside it. So the liquid is going to pass on the body of the glass rod, and it's going to like stop any metal or any solid that will start passing. You understand? So when you get to the solid part, you are going to stop. So this is a very fast method, but it is inaccurate. You understand? So that is decantation. So the next thing is filtration. So if you hear anything about filtration, so the first thing that should come to your mind is filter paper. Filter paper. So when you use filter paper, you can fold the filter paper and use it to filter a solution of solid and liquid. You understand? So when you get, instead of getting to, like, just unlike decantation, that when you get to the solid part you stop. In filtration, you are going to pour everything inside the filter paper. So the filter paper will drain out all the liquid and the solid will stay on the filter paper. Understand? So the next thing now is centrifugation. Centrifugation is a kind of technique that you use a machine, a centrifuge machine, to spin a mixture that contains a lot of things. You can use, it can be homogeneous or heterogeneous. Use it to spin that thing continuously until it separates into different layers. You understand? So that is centrifugation. So they use it in hospitals to test blood. So when they use the centrifuge machine to spin continuously for like 5 or 10 minutes, so the blood is going to separate into different portions. So the solid, they will separate according to how thick they are. So the thickest part is going to be under, so followed by the next thickest, followed by the other one. So that's how it's going to be arranged in the test tube. The next thing is flotation. So what is flotation? Flotation is, there are some ores of some earthly metals that are found in low concentration. You understand? So they are found as mostly sulfides. So these sulfides need to be concentrated, like put in high concentration, before they can be sold. So how do you put them in high concentration? They must first go through the process of flotation. So how do you start flotation? You need to ground the ores. You ground them into finely ground ores. You understand? Very, very like powder. So when you ground them, then you pour them inside a very big basin. Then you pour water. So when you pour water, there are some of the ores will be dissolved by the water, and then some that are not dissolved go down. So the ones that are dissolved, so you pour them away. So they are going to float on top, then you pour them away. That's just the basis of flotation. So the next thing is evaporation to dryness. A solution contains solute and solvent. Solute is the solid things that you dissolved in water. Solvent is the water mostly. So the solute is those solid things that you dissolved in the solvent, which is water. So if you want to get your solute back from a solution that has water, then you can evaporate. So the water is going to leave. Water has boiling point is around 100 degrees. So it's going to leave, and leaving the solute at the bottom or inside the boiling tube. So we'll be moving on to crystallization. So in some cases whereby you can't use evaporation to get your solute in the solution, so you can use crystallization. So crystallization, there are some compounds that they decompose on heating. So when you heat their solution, they start to decompose, and you won't get your solute back. So you can use crystallization. Crystallization is just that instead of boiling, you start adding the solid of that solution. What am I saying is that just as if you are making amala at home. That's just the best example. So you've poured the amala inside the hot water. So instead of and the hot water is too much, or is more than the amala that you have. So for you to get the solid amala, the best thing to do is to keep adding more of the amala, you understand, until it gets solid. So that is crystallization. So the next thing is fractional crystallization. Fractional crystallization It's just that when you have two or more solids, or two or more solution, two or more compounds inside a solution, and you have to get the solid of, or you have to get a crystal of one of them outside, or more, or one or more. You know, they have different solubilities. These compounds, they have different solubilities. So you can keep dissolving it in water. So the ones that has the lower solubility will first dissolve, then you can bring that one out and then add the solid of that one to it. So that is fractional crystallization. You do it that way, and then that's how you do. That's what fractional crystallization is. The next thing on the line is precipitation. So what is precipitation, or how do we use precipitation as a separation technique? So precipitation can be explained as when you have a solid, you understand, or a solute, and there are two miscible liquids. One of these two miscible liquids can dissolve the solute, but the second one cannot dissolve the solute. So we use precipitation. Well, this is precipitation, you understand. So if, for example, water and ethanol are both miscible, you understand, they can mix with, ethanol can dissolve in water, but we have a solute like copper sulfate. Copper sulfate can dissolve in water but cannot dissolve in ethanol. So if copper sulfate is dissolved in water, you understand, and you want to get the copper sulfate back, what you need to do is pour ethanol into that solution, or into the solution. So the copper sulfate to precipitate out of the solution. It's going, because ethanol has mixed with water, so it will force that copper sulfate to leave the solution. So that is precipitation. So as we've been discussing before, we know that solution equals to solute plus solvent, right? So we've been discussing how to remove the solutes from the solution. Now, how to get the solute. So now we are going to how to get the solvent. So which is where we are going to distillation. Distillation is when there is distillation, your aim is that you want to get the solvent, right? So the solvent is also known as the distillate. So you heat the solution, and there is a connection. You can check your textbook. So it's just like a round bottom flask, so, or a flat bottom flask, as the case might be. So you put a condenser. So the condenser is usually like a slant, something like this. So when the solution, or when the solvent gets to its boiling point, to start boiling, so it will pass through the tube into the condenser, so you can collect it at the other side of the condenser, you understand, inside another test tube or another flask. So that is another conical flask. So that is distillation. So fractional distillation, when just like this, like fractional crystallization, fractional distillation is when you have two or more miscible liquids as the solution, in the solution, you understand, and you want to get each of them. So you heat them. When the first one, or the one with the lowest boiling point, when it gets to its boiling point, it will boil out of the solution, and you collect it into one flask. Then when the second one gets to its boiling point, or the one with the next high boiling point, so it's going to boil again, and you collect it into another flask. So that's how they extract petroleum. So petroleum contains a lot of is a mixture, you understand, it contains a lot of distillates. So one of it, for example, is petrol. So when petrol gets to its boiling point, it will boil out of the solution, so they will collect it in a place. Then when kerosene gets to its own boiling point, it will boil out, and it's going to be collected inside another place, you understand. That's how they extract petroleum. So the next one is separating funnel. Separating funnel is just like when you have two immiscible liquids. Please note it. Two immiscible liquids. Two liquids that do not mix. So, there's going to be a portion of them. The one with higher density will be under. The one with lower density is going to be up. Just like when petrol mixes with water, or when kerosene mixes with water. So the one with the higher boiling point, the one with the higher density is going to be under. The one with the lower density is going to be on top. So you pour it into a separating funnel and you allow it to wait for a long time, you understand, so that it will settle, and then you open the mouth of the separating funnel to take out the one under first. When it gets to the one on top, so you stop, you understand. It's an inaccurate method, but still it is going to get you what you want. The last but not the least thing on separation techniques is chromatography. So what is chromatography? Chromatography uses a solvent moving over a porous adsorbent medium to separate a mixture of solids. What is this thing telling us? This word adsorbent means to hold, you understand? So chromatography uses when a solvent is moving over a porous medium, e.g. paper or gel, you understand. The gel or paper, for example, when you pour something on it, some of it is going to pass through it and some is going to hold, like stay on top, you understand. So that is chromatography. It's just like sieving, but it is a more complex type of sieving. Paper, for example, it has very, very tiny holes, you understand. So when you pour a solution on it, so it's going to dissolve, like some of it is going to pass through and the ones that are thick is going to stay on top. So that is chromatography, and this can be used to separate colored or colorless solutions. So the colored solutions like inks, dyes can be separated by chromatography, and the colorless ones like amino acid can also be separated by chromatography. So the main examples of them or types of chromatography is paper chromatography and gas chromatography. So to cap it all, I'm going to be talking about test for purity. So test for purity, what is this thing telling us is that how can we know whether a substance is pure? You understand? So the first test is that, or the first thing to note when you are testing for purity is that the melting point or the boiling point of a pure substance is fixed at a given temperature. You understand? What is this thing telling us is that the melting point of a solid or the boiling point of a liquid that is pure is fixed at a given temperature. It's not that it is in between 100 to 200 degrees or between 100 to 150 degrees. At the given temperature, if it's going to be 100 degrees like water, then it is 100. Pure water should boil at 100 degrees. Or a solid, like for example, a solid that has the melting point of 120 degrees should, when it gets to 120 degrees, automatically it should melt. It's not like when it gets to 120, you'll have to wait till 150 to check maybe it is melting or not. You understand? That is the first thing. So when you add impurities into a pure substance, then the melting point or the boiling point is going to shift. So in our coming classes, we are going to tell you which one will shift to the front or which one will increase and which one will decrease between melting and then boiling points when you include them impurities. So the second point to note is that a pure substance gives one spot on a paper chromatogram. So you can be asked in your JAMB exam, how many spots does a pure substance give on the paper chromatogram? So definitely you should know that it gives just one spot. So that is all on this topic. Make sure you like, share, and subscribe to our YouTube channel. and share to your friends, all your friends that are writing jump next year. Thank you so much. See you soon.